Hello everyone and welcome to this Python tutorial on computer vision using OpenCV. In this tutorial, we will be covering how to perform tasks such as object detection, image segmentation and facial recognition using OpenCV. So introduction of the OpenCV, that computer vision is an exciting field of an artificial intelligence that aims to replicate and enhance human visual perceptions capabilities using computers. It involves developing algorithms and techniques that enable machines to interpret, understand, and extract meaningful information from visual data such as images or videos. By leveraging advanced image processing, pattern recognition, and machine learning techniques, computer vision enables computers to recognize objects, identify and track their movements, estimate depth and distance, perform image segmentation, and much more. It finds applications in various domains, including autonomous vehicles, surveillance systems, medical imaging, augmented reality, and robotics, revolutionizing industries and driving advancements in AI technologies. Here are some practical implementations. So let's start with object detection. Object detection is a process of detecting objects in an image or a video stream. We will be using OpenCV's built-in HARR cascade classifier to detect faces in an image. Here is the code. So we need to import CV2, then we need to load the cascade, har cascade, frontal face default dot xml. Then we need to read the input image, here input.jpg. For example, convert it the image into grayscale. So for that we need to use cv2.cvt color, and in that cv2.color underscore bgr to gray. So this is the bgr image. We need to convert it into grayscale image. Now for detecting faces, we need to have a variable faces, that face underscore cascade, our cascade variable dot detect multiple scale, and gray 1.1 and 4. Draw the rectangle around the faces. So for that we need four variables. For x y w h in faces, cv2 dot rectangle, we need to plot the rectangle face. The first point is xy and the last point is x plus w comma y plus h. 0 comma 0 comma 255, there is rgb color, a blue color, blue rectangle, and 2, that is the thickness. Then we need to display the output cv2.imshow and wait key. Here we load the har cascade classifier, read the input images, convert it into grayscale, and then detect the faces in the image using detect multi-scale method. We then draw a rectangle around each faces using the rectangle method and display the output images using the imshow method. Next, we have image segmentation. Basically, image segmentation is the process of dividing an image into multiple segments or regions, each of which corresponds to a different object or part of an object. Here we will use watershed algorithm to segment an image. Here is the code. Import CV2, import numpy. We have to load the image, convert it to the grayscale. Now we need to threshold the image. For threshold, we need to have cv2 dot threshold, and that we need to pass the grayscale image 0 comma 255 cv2 dot thresh binary underscore inv plus cv2 dot thresh otsu. This is used to threshold our image. It will give the two outputs, so we need to have two variables, ret return and thresh. For noise removal, we need to have a kernel 3 by 3, and with the use of openings, we have morphology ex. Using that kernel and having argument iterations 2 and cv2 dot morph underscore open. We have removed the noises in the image. We can have a background area by dilating the image. After that, we can find the sure foreground area by using CV2.distance transform. And after that also we need to threshold our image. Now we need to find the unknown region for the images. And after that we need marker labeling, add 1 to all labels so that sure background is not 0 but it is 1. So now mark the region of unknown with 0 and apply the watershed algorithm. This is the inbuilt algorithm, cvt.watershed. We need to pass the image and markers we have created, and after that we need to display the output. So here we load the input image, convert it to the grayscale and threshold it to obtain a binary image. We then perform a noise removal using morphological opening and extract the sure background and sure foreground areas. We use the distance transform to obtain the distance of each pixel from the nearest 0 pixel and threshold it to obtain the sure background foreground area. We subtract the sure foreground area from the sure background area to obtain the unknown region. We then use the connected components function to label the markers and apply the watershed algorithm to segment the image into different regions. Now we have moved to the practical implementation of facial recognition. For that, we need to import the CV2. We have used a classifier har cascade frontal face underscore default.xml. We need to load the recognizer cv2.face.lbph face recognizer underscore create. We need to read the image and label it by converting it into grayscale BGR to gray. Train the recognizer. We need to train it using the faces variable that we have appended in the gray and np.array and labels. We have then read the test image. We can convert the grayscale. We can detect the faces, recognize the faces, and display the output. So here we load the har cascade classifier and the lbph recognizer and read the images and labels for training the recognizer. We then train the recognizer using the train method and read the test image for recognizing the faces in the image. We detect the faces in the image using detect multiscale method and recognize each face using the predict method of the recognizer. We then draw a rectangle around each face and display the name of a person if recognized or unknown if not recognized. We can see this in if else condition of the for loop of faces. If confidence is less than 100, we have to give put the text of the person name, person ID. And if confidence is greater than 100, we have unknown. Now the real life examples of computer vision. So computer vision has wide range of real world applications such as autonomous vehicles, medical imaging, and security. For autonomous vehicle, computer vision is used in autonomous vehicles for tasks such as object detection, lane detection, and pedestrian detection. For medical imaging, computer vision is used in medical imaging for tasks such as image segmentation, tumor detection, and diagnosis. Computer vision is used in security for tasks such as facial recognition, object detection, and tracking. Talking about the real life company who uses CV library in main. So Amazon is a large e-commerce company that uses computer vision to improve its warehouse operations. Amazon's warehouses are filled with millions of products that need to be picked, packed, and shipped to the customers every day. To speed up this process, Amazon uses computer vision to automate tasks such as product sorting and inventory management. Amazon's computer vision system uses cameras to capture images of the products and barcodes in the warehouse. The system then uses machine learning algorithm to analyze these images and extract information such as product type, quantity, and location. This information is used to generate optimized picking route for the workers and to keep track of the inventory levels in real time. By using computer vision to automate these tasks, Amazon has been able to reduce the time and cost of warehouse operations and to improve the accuracy and efficiency of the picking process. This has allowed Amazon to handle a large volume of orders and to offer faster and more reliable delivery to its customers. That's it for this Python tutorial on computer vision using OpenCV. We covered the object detection, image segmentation, and facial recognition, and saw some real world applications of computer vision. Thanks for watching and see you in the next video.